Hiya! So in this video, we're going to look at a continuous version of a cumulative distribution function. So normally when we have f sub x of x, so a cumulative distribution function, we normally write this as CDF for short. Because as you've noticed, it's hard to say, hard to write. CDF kind of works nicely. So this, remember, is equal to x less than or equal to x. And this, by definition, is given by this. Right? And so the main thing here is to kind of note that I guess I should not be using x because I have an x up top. So I should do y. So f sub x of y dy. And if you notice one thing, and here this is going to take some time to think, but remember that a distribution has the three parameters, right? One of them being that the area has to be equal to 1. So what this means is whenever I look at minus infinity, this has to go to 0, right? When I plug in minus infinity, it has to be 0. Because if it's above 0, that means I'm adding an infinite number of things that are positive or negative. So my area would not be 0. So it kind of, like, in essence, most of the time, this is not always true, but most of the time, you can kind of see that this is probably going to be going to 0. And so this, if you kind of look at this also, like from our previous talk about the fundamental theorem of calculus and all that, you can kind of see that f sub x, the big one, is just the antiderivative. So a lot of times we can just think of it as the antiderivative of our function. So let's kind of look at this and kind of see what it gives us. So let x be a random variable which has a standard uniform distribution. So in other words, x is uniform on 0, 1, right? So that's standard uniform. And we're asking what is its cumulative distribution function. So first, let's look at what the function looks like. So this is the function of x. So this is badly written. This is f sub x of x, right? This is given as 1 for everything between 0 and 1, and 0 otherwise, right? So this is our graph, right? It's 0 everywhere. Here, it pops up, and then comes back down, right? So this, you might be like, wait, but this doesn't look, I don't know why there's the vertical ones. This doesn't look continuous. Why would this be a continuous distribution? Well, because let's look at its CDF. It's a cumulative distribution function. So basically what we have is we have to calculate the areas, right? So up until 0, the area is 0. So basically up until 0, the area is 0 and nothing happens. And then let's look at like a tiny little mini example. So here if I have 1/2, for example, well, what's the area of everything at 1/2? Well, it's basically just this thing, right? So the area is equal to 1/2. So everything less than or equal to x, which is p of x less than or equal to 1/2. So in other words, when I do 1/2, I should get 1/2. That's what we're drawing here, right? So this is my f sub x of x. This is wrong too, these labels. It's right on my side. I wonder why it's wrong on yours. Maybe it's not updated? I'll have to see. And so if you think about this, at 0, the area is 0, which is why we have this kind of thing. And we're adding things constantly, right? It's a linear addition from left to right. So like if I were to do 3/4, it would be 3/4. If I did 1/4, it would be 1/4. So if we kind of look at all these points, so 1/4 would be 1/4, 3/4 would be 3/4, right, etc. And this gives us the function. So here is, oops, that. And then from here, it keeps going at 1. And here you notice that the CDF is continuous, right? Like even at these little edge points, this is continuous. You might not be able to take the derivative, but it's continuous. Remember, continuous basically means that the point exists and the limits from both sides are equal to one another. So the limits from both sides are equal to one another and the point exists. So in this case, we can kind of see that, yes, we do have a continuous function. And that's basically how to do that. So we'll stop here. And in the next video, we're going to be talking about maximum and minimum independent random variables. So it should be fun. So I will see you then.